Why is water sometimes a rock, sometimes a cloud, and sometimes nothing? The answer lies not in the water itself, but in the invisible force that commands all matter called energy. Everything you see, touch, and even breathe is in a constant dance, a battle between holding together and flying apart. It's a dance choreographed by energy. Lose energy, and particles huddle for warmth. Gain energy, and they yearn to break free. Today, we're not just looking at solids, liquids, and gases. We are diving into the fundamental rules that govern our universe, revealing how a single substance can wear so many different masks. This is the story of matter, told through its master, energy. Let's shrink down, past what our eyes can see, to the world of particles. Imagine a grand cosmic dance floor. In a solid, our particles are locked in place, shoulder to shoulder in a rigid, perfect formation. But that's what you see. Actually, they aren't still. They're vibrating, humming with contained energy, holding a definite shape and volume. Think of a block of ice, a disciplined army of molecules. Now, let's turn up the music. Add a little more energy. The particles are no longer content to just vibrate. They start to break formation, sliding and gliding past one another. This is a liquid. They are still close, still touching, but now they can flow, taking the shape of whatever container holds them. The army has become a crowd, moving together but without rigid discipline. What happens when we crank the energy to the max? The particles go wild. They break free entirely, ricocheting off each other and the walls of their container with chaotic speed. This is a gas, no longer touching, no longer contained. They will expand to fill any space they are given, a frenzied, invisible swarm. This isn't just about ice, water, and steam. This is the particle dance, the fundamental behavior of matter everywhere. Solid, liquid, gas, 3 different performances, all starring the same particles, directed by the presence or absence of energy. Our journey begins with the solid, the most orderly state. Here, particles are locked in a crystal lattice, vibrating but immobile. To change this, we must inject energy. The first transformation is the most familiar: melting. As we pump heat into a solid, we're giving each particle a jolt of power. They begin to vibrate more and more violently, straining against their bonds. Finally, they break free from their fixed positions. The rigid structure collapses, and the solid dissolves into a flowing liquid. The army has broken ranks. But what if we give them an overwhelming surge of energy? All at once, we can force the particles to skip the liquid phase entirely. This is sublimation. The particles gain so much energy so quickly that they don't just break their bonds, they shatter them, launching directly from their fixed solid positions into the chaotic, high-speed freedom of a gas. Imagine a block of dry ice, not melting into a puddle, but vanishing into a dense, heavy cloud. It's a dramatic escape, a testament to the explosive power of adding massive amounts of energy. Now we arrive at the liquid state, the middle ground, the crossroads of matter. From here, we can go in 2 directions. Let's start by adding more energy. As we heat a liquid, the particles, already sliding past one another, begin to move faster and faster. This is evaporation. At the surface, the most energetic particles can finally overcome the pull of their neighbors and escape into the air as a gas. But if we keep adding heat, we get a much more violent transformation named boiling. The energy becomes so intense that bubbles of gas form deep within the liquid and erupt at the surface. It's a chaotic, roiling conversion, as the entire body of liquid energetically transforms into a gas. Now, let's reverse the flow. Let's start pulling energy out of the liquid. As particles lose energy, they slow down. The gentle sliding becomes a sluggish crawl. They begin to feel the pull of their neighbors more strongly. This is freezing. As we remove more and more heat, the particles stop sliding altogether. They find their positions, lock into place, and the fluid motion screams to a halt. A rigid, crystalline lattice snaps into existence. The free-flowing crowd of particles has been forced back into the disciplined army of a solid from liquid. Energy decides the path for them. Will the particles fly free or be locked down? We now find ourselves in the world of the gas, where particles are at their most energetic and free. To tame these, we must remove that energy. As a gas cools, its fast-moving particles begin to slow down. They lose their frantic momentum. This allows the subtle attractions between them to take hold once again. They start to clump together, forming tiny droplets. This is condensation. You see it every day, as the invisible water vapor in the air cools against a cold glass, revealing itself as liquid dew. It's the capture of chaotic particles, forcing them back into the gentle, flowing dance of a liquid. But just as we can skip the liquid state on the way up, we can also bypass it on the way down. What if we remove energy from a gas with shocking speed? The particles don't have time to form a liquid. They go from high-speed chaotic flight directly to a locked, solid structure. This is deposition. The particles lose their energy in an instant and are frozen into place. Think of the delicate, intricate patterns of frost forming on a window pane on a frigid night. Water vapor in the air, upon contact with the freezing glass, doesn't become water first. It becomes ice. A direct leap from chaos to order, all because energy was stolen away in a flash. For centuries, we thought this was the end of the story. Solid, liquid, gas. But we were missing the most common state of matter in the entire universe. What happens if you take a gas and pump it with so much energy, so much extreme, overwhelming heat that it does something even more dramatic than just expanding? The particles themselves begin to break apart. Electrons are stripped away from their atoms, creating a superheated, electrically charged soup of ions and electrons. This is plasma. It is not a gas. It is a fourth fundamental state of matter. You've seen it. It's the searing, jagged channel of lightning that tears through the sky. It's the glowing heart of a neon sign. And it's the engine of our sun and every star you see in the night sky. While we live on a planet dominated by solids, liquids, and gases, the vast, overwhelming majority of the visible universe, over 99%, exists as a galaxy of plasma. It is the state of matter born from truly cosmic levels of energy. There, you have it. From the rigid lockstep of a solid, to the sliding dance of a liquid, to the chaotic freedom of a gas, and finally, to the incandescent fury of plasma. And between them, 6 pathways of change: melting, freezing, boiling, condensation, sublimation, and deposition. It's all one story, written by a single author, named energy. Its addition or removal dictates everything. You now understand the fundamental forms of the universe, from a single snowflake to the heart of a distant star. Thank you so much for joining us on this cosmic journey. If you enjoyed demystifying the universe with us, be sure to hit that subscribe button and ring the bell so you don't miss our next adventure. Let us know in the comments which state of matter you find the most fascinating. Until next time, stay curious.